Hey everyone, this Maths Guy channel here, and today we're going to be solving the truncus, the square root, and the cube root function. Alright, so the truncus. Building on from the last lesson of the hyperbola 1 over x, the truncus is a variation of it, 1 over x squared. And if we just type it up here, you see that it's not that different. The first thing you're going to see that the range, because here the range is only from 0, it's an asymptote, all the way to infinity, and x, the domain, is all real numbers. That's the first thing you notice. As no x equals 0, y equals 0. It's a many to 1 correspondence. So if you were to do the horizontal line test, so x equals, I don't know, 2, y equals 2, you see that it will pass the vertical line test at every point, but it will fail the horizontal line. As an example here, it's only 2 points of the function. So it's a general form. So here is a over x minus h all squared plus k. So we just type that in. F of x equals a over x minus h squared plus k. Let's get rid of this. And as per usual, k is up and down. Nothing special there. H is side to side, nothing special here. So we just set this at 1. And A, as per usual, is dilation. And once it flips, it goes over to the negative side. Okay, so that's pretty clear cut. Solving for x. The algebra is quite simple. However, you'll notice that graphs like this, there will be no, keep in mind that sometimes you will not have any solutions in x-intercepts. And sometimes no y-intercepts if the asymptote is 0. Okay, and this is just saying the range here. As you saw earlier, that if the range is above, the range is just set this to 0 and 0. So if it's above 1, the range is from 0 to positive infinity. If it's negative, then it's opposite. But you get the idea. Right, next function, the square root function. So this is x raised to a fraction, so 1 over 2, so the square root of x. And if we just graph it out here, square root x. Okay. So this is what it looks like on its own. Right, and if you solve, instead of y equals x squared, this is y squared equals x. You can see that the this is a part of the parabola, the other part is negative x. No, negative x here. It satisfies y squared equals x. You have this function here. So your negative outside flips the x values. You can see here, I'm going to put a negative here, it reflects over the y-axis, and if I do both, unsurprisingly, you get this. And yeah, so this is the basic form of the square root function. And if you do general form, so a times x minus h plus k, and for all, you can keep plugging as a is side to side, k is up and down, a is dilation, if it's negative it flips, and yada yada. You guys understand it. Yeah, once again, with squaring in terms of algebra, solving is algebraically. You can have situations where you will have no solutions, like here. There's no x-intercept, or in this case also no y-intercept either. The endpoint is at the coordinates hk, obviously. So if I make this 1 here, see it's 1 1. And if I change either of these, also it's a. But if I change any of these, then yeah, the endpoint changes. And this endpoint exists because, like, for example, if I get we talked about the maximal domain. If I write down square root of x, right, you can see that. If I were to solve x squared equals, if I solve negative 1 here, no solution comes out because you have a negative inside the set. And the graph here demonstrates that it only accepts 0 or positive numbers. Lastly, we're going to quickly go through the cube root function. Same sort of manner. So let's choose 3. Yeah, it looks like x looks kind of like this. So usually it's like it's going to be flips in that sort of way. And most of the rules are similar except flips because yeah, the of the way the function is expressed. So you have the point of inflection at 0, 0, the origin, as usual. Its general form is how do I write this? A times minus h plus k. That's probably quicker doing that, but that's alright. And as per usual, h, k, a flips as per usual. And yeah, with a function like this, you always get an x and y intercept, unlike the other function, because this is I think like this is similar to the cubic in that you'll always go through. If I draw, for example, y equals x cubed, or and I keep changing this to odd power. You see that even if I change the coordinates, it will always go through the x and y axis. Whereas if I do even power here and I do a +1, you can see that simply by doing that, it avoids touching the x axis. Yeah, as per usual, the domain and range are so all real numbers. As you can see, there's no asymptote or anything, no limits. And yeah, though to be honest, you usually won't go across the square root. Let's not the square root, the cube root function. You'll see the truncus and the square root function a lot more. Simply because when you're doing algebra, you go through the powers with the x with the square root, normal square root. And yeah, that'll be all.